Bismillahirrahmanirrahim. Good evening, guys. Today we will illustrate the important information about the how we can determine, how we can test the IV curve to the diode. Our previous lecture, when I was talking about the resistance, we used IV curve. Here too, we will use IV curve to determine the characteristic of the diode. But at first, the student must be what is the semiconductors, where is the semiconductors element in the periodic table, what is the p-n junction made from what's its impurities. The p-n junction is the most important thing to make the diodes, transistors, p-n junctions, and at the last, and our topic today is the diode. Here, let's take a fast look to these slides. The purpose here to determine the characteristic of semiconductors between two brackets. The semiconductors here will be the diode. That's my topic today in the lab, to determine the characteristics of the diode. We know the curve how will be, but we won't test that. We won't be sure from that, because that we have experimental work. We will do it at this week. What is the semiconductors? Where and when will be conductors? When and where will be isolators? What is the p-n junction? What its impurities, and the p-n junction diode, the diode connection, and at the last we will have a comparison between the diode and resistance. Here the purpose to determine the characteristic of the semiconductor, specifically diode. Introduction: a semiconductor material normally acts isolator. Actually, semiconductors in some condition act like isolator, and somehow in some temperature will act at like any conductor, because that it's very interesting topic to the researchers, because it has two different characteristics at the same element. The semiconductor here at this periodic table, if you don't have any idea about the periodic table, unfortunately, you must take a look to it and study to can know some simple information about it. For example, where is the semiconductor? The semiconductors at this line here are these squares, which each one has the different color that acts to different material. For example, here at the middle, it's transition materials. Here, alkaline earth. Here, rare earth material. Here, the semiconductors material. Okay, the semiconductors, two types: elements or compounds. Elements like silicon, germanium, and compounds like gallium arsenide. Here, what is the p-n junction? The p-n junction, the lab, the researchers, the workers made it very carefully with specific conditions, specific temperature, specific purity. When it's pulsed with electricity at certain voltage, it becomes, let's focus on this certain voltage. We will take a deeply idea on it at the last slide. It becomes electrically conductive for that moment and acts like an electrical bridge, to be like any conductor. The diodes are a kind of the p-n junction. Like I said before, from the p-n junction, all of the solar cell, diode, transistors, yes, solar cell, transistors, diodes. Yes, I think it was for solar cell. PN junction, diodes, and maybe I forgot one of them. Okay, all of these are made from the PN junction. What is the PN junction? What is the most important contents to the PN junction? Actually, it's made from two sides, N-type, P-type. Between them, the depletion region. Why it's N-type and it's negatively charged. P-type is positively charged. P-type, it's filled with holes. N-type with holes with electrons. That's according to the which element we used to doping this PN junction. Here, we will use element has electrons at the last shell, because that will donor them to this side to be full with electrons, to be N-type. Here, which element I will use will take electrons from this side to can reach the stability level. By that, this side will be full with empty. I think the impurity elements were boron and phosphorus, pH and Ba. By that, the depletion region will happen. Like I said before, it's an interface between two types of semiconductor, silicon and material silicon. These types are N-type, negative, P-type, positive. Inside the single crystal of semiconductor, PN junction are basic units of most semiconductors. Electronic device, like I said before, diode, transistor, solar cell. Junction, this picture illustrates to us the out shape of the diode. And actually, I bring some diodes to you. I will show some different types of diode in the next lecture, inshallah. The junction diode is a basic semiconductor device that controls the flow of electrical. Like I said before, like a bridge and like a wall, and sometime like a bridge, at another time like a wall. Sometimes we use it to make the current flow. Sometimes we use it to be like a wall to prevent the current from flow. It has a positive side and negative side created by adding impurities to each side of silicon semiconductor. Here to connection, we have a diode, forward direction and reverse direction. At this experimental, we will focus on just forward direction. The diode in forward direction, when an external battery is connected, positive will be with P-type, negative will be with N-type, reverse will be reverse that. Unlike charge will connect together. Current flow in the forward direction is very large compared with that in the reverse direction. Here we can take a look to this voltage. At forward voltage, the current will start to change its direction from approximately linearly to be exponentially increasing. Here at silicon 0.7, germanium 0.3, it's less than silicon, but here it's less than. Here the voltage. We was talking about the current. The current at the forward direction will be more than, larger than at reverse. Here it's a simple comparison between the diode and resistance. At diode flow of current in one direction, just one direction. And resistance permits the current to flow from two directions. A diode IV characteristic is non-linear. It's as started will be acts like line. After that, at some specific voltage will increase exponentially, but at resistance IV curve, it's specifically definitely it's linear. A diode in forward direction, the current will not pass through the diode until reach the certain voltage VF. But at resistance, the current will pass through the resistance immediately after the voltage is applied. We don't have specific voltage to make the current flow. At last, used rectifiers turning. Here it's important. Here we use the diode. Another benefit by using the diode, turning, converting AC current to DC current, like the rectifiers, work. But the resistance here used to reduce the current flow, just to reduce the current flow. Here we will work to determine, to prove this curve is right. In the lab, just add forward bias and we will know what is the forward voltage. Here at this column, the question in your exam will be determine the forward voltage at forward bias and characteristics of this diode according to the column below. Which column? This column. Here at this connection, I have diode and is connected parallel with the voltmeter, series with the emitter, with the R resistance. That's mean its resistance with, but can give different value. Okay. Power supply. By increasing the power supply and change the R state, we will reach this value at first 0, 0. After that, the current will be constant at 0 approximately, and the voltage will increase step by step. Like here, 0, 1, 0, 2, 0, 3, until 0, 5. Until 0, 5, the current will jump from 0 to 10 milliampere, 0.660, 0.780. By that, by using this curve, here, all of these results here, from 0 to 0.4, it was 0 at y-axis at current milliampere, until reach 0.5, the change is started. The line started to convert its shape to be like curve. 0.5 here at 10 milliampere and 0.6, 60 milliampere, 0.7, 160. By that, we determined this curve, and it's true. We did that by using our hands. The purpose is done. Thank you about your watching, your listening. Have a good day. See you in the next lecture.